Okay, so we just mentioned that your homework is due on Monday. Is there anybody who's close to being completed with it? Okay, Bennett? Anybody else? Everybody started it? Yay! All right, there you go. So that's on Monday. I am going to go ahead and have a quiz on Tuesday over the material. Another nice little quiz. Hopefully, help you get prepared for Thursday's exam next week. So that way, if I give it on Tuesday, I can return that on Wednesday. You got another resource to look at, along with your assignments, the notes, all that. And hopefully, you are already taking the time to look over the material, because this first test is made up of 3 lessons. The language of functions, which we're done with, graphs of functions, which we will complete today, and then piecewise functions will start Monday. Sandra? I haven't decided yet. I'm thinking about that. I'll let you guys know. Okay, that's a good question. Let's see. As far as in class, that's it. What about drills next week? Tuesday during what period? First period, you got your fire drill. Now, on Wednesday, it's 4th period lockout. So that's business as usual. What period Wednesday has the lockdown? 7th period. Okay, so hopefully, again, if you have any questions about that, let me know. Thursday, 8th period is our first pep rally. Go team. Okay, so that's not going to affect us. I mean, the pep rally will be much later in the day, but we are still testing that day. That's all I got, unless anybody... Oh, there is one other thing. I did put it up here so I wouldn't forget. I do have several people who are still turning in their homework, and if you're doing so, thank you. But I always want a hard copy. I should have mentioned that before. So some people are submitting it on the Google website. So if you did, again, thank you, but I would like a hard copy. Always go ahead and give me a hard copy so I can actually take a look at it. Okay. So that now is all I got, unless anybody has any questions about what's coming up. All right, well, let's go on with our lesson here. Now, we finished up with relative maximums and minimums yesterday. I'll go ahead and kind of bring back the definition in just a second. But this next section talks about approximating extrema. Now, when you hear the word extrema, I want you to think of maximum and minimum. Okay? And in turn, when you think of maximum and minimum, think about the y value associated with a particular point. Because when we say maximum and minimum, we are talking about the y value. Okay, so let's say this graph right here, the one that's x cubed minus 4x plus 1, definitely goes forever above and below, bless you. Okay, so this point right here, if I were to go ahead and find the coordinate, which we are actually going to do in just a moment, but think about that y value. Is that y value at that location the absolute largest y value element of the range the entire graph has? Okay, no, because it's infinitely tall. He goes all the way to positive infinity, right? Now, what the definition was saying yesterday was, okay, it may not be the overall largest, but if I go ahead and create an interval from some value of x to another that contains that point, if I'm solely looking at that interval, is that now the largest y value? Yes, that's what we're referring to as the relative maximum. Remember yesterday I referred to it as the peaks and the valleys? Okay, so this one right here, he would be a relative minimum. Definitely not the smallest y value that we have overall, but it is if you go ahead and create a interval. Okay, so what we're going to do now is, given this graph, let's go ahead and determine that actual coordinate. I want the local extrema. I want to know where it occurs at, so the x value, and I want to know the local maximum value. And local is just another term that they could use instead of relative. They could have easily said relative maximum value, and it would have been just fine. Okay, so let's go ahead and plug this in the calculator. X cubed minus 4x plus 1. Let's see here. X cubed... Was it plus 4x or minus 4x? Minus 4x. Minus 4x plus 1. Okay, so there's the graph that we have on our paper. So I'm going to go ahead and show you how to do this on the calculator. Okay. So now let's say I do want to go ahead and find the coordinate of this point right here. I want that relative or local maximum. Alex. Oh, you already know the answer? Okay, well, do you remember, walk me through the process you used to get that.
All right. So you start by finding the graph and you push the menu button.
Okay, so I got the graph. He says push menu.
Go down to number 6.
Okay, analyze graph.
And then go to the maximum and minimum.
There you go. In this case, we're looking for the relative maximum, so I'm going to choose that. Okay, so we went to menu, 6, analyze graph, and then what was it, number 3, maximum? Okay. Now, you're going to notice it gives you a vertical line. It's got a little hand on it. Kind of looks like the Texas Tech guns up sign. Okay. Bottom of the calculator says lower bound. I'm looking for this coordinate right here, so it's telling you you want to place that vertical line to the left of the point that you're looking for. And you can actually, play around with this. You can actually go far left or right of it, and it'll still give you what you want. I like to go ahead and just put it right over to the side. So as soon as you have a spot you want, click enter. It's going to mark that location, but you'll notice lower bound is now what? Upper bound. So think if the lower bound is on the left, upper bound is on the right. Okay, so as soon as I sweep it across, if it hits that point, it's going to go ahead and pop up that location. Okay, so there we go. So I know it occurs at negative 1.15, and that relative maximum is 4.08. Is everybody okay with how I got that? Okay, so let's write it down. Let's see, it occurred at x equals negative 1.15. That value was 4.08. So this coordinate right here is negative 1.15, 4.08. There we go. Okay, any questions on that? Easy, right? Okay. Well, why don't we go ahead and do the same thing in order to find this relative minimum. Okay. So let's see here. Alex said I'm going to choose menu, analyze graph, but now I'm going to choose minimum. You do want to be specific about the one you're choosing. Okay. So again, I'm going to put this just to the left. Okay, I want this point right here. So to the left, I'm going to push enter. It changes to upper bound. And now I'm going to slide that across. Okay, so here's that coordinate. I know the x value where it occurs at, and I know what that local or relative minimum is. Okay, we can just go ahead and write that on the paper. Okay, so it occurred at x equals 1.15, and the minimum was, what was it, negative 2.08? Okay. All right, so this is all you're going to be responsible for right now. If I do, want you to go ahead and find the relative maximum or minimum, okay, and it's not, obvious from the graph if it's going to be some kind of decimal value. I know you're probably saying, Mr. West, that's way too easy. I want another way to go ahead and solve that that's more hands-on. Okay, I hear you. Okay. Let's say I want to go ahead and find this point right here. Okay, but I'm not going to go ahead and just rely on technology to go ahead and do that. If I wanted to go ahead and find the value of these relative maximums and minimums, I would use what's called the derivative. Okay, has anybody ever worked with a derivative before or had some experience with that? Okay, now the derivative of a function is really, really useful to us. There's a lot of applications. I'm not going to go into a lot of detail here, but let's say it revolves around the idea of a tangent line. What am I saying when I say tangent? How many points of intersection would you have? Just one point of intersection. So you'll notice if I go ahead and say this particular point right here, okay, if I know the derivative of this function, and I plug in the corresponding value of x at that location, it'll give me the slope of that tangent line. Okay, that's how you're going to go ahead and first be looking at the derivative. The derivative is going to give you the slope of a tangent line at any value of x that you want. So let's say I want to know what the slope of the tangent line is right here. Okay, well, I would plug in that value of x into the derivative. Or it could be here, it could be here. So you'll notice as you go through, the slope isn't consistent. It's not a linear function. It's going to be constantly changing, right? Now, what we're interested in are those relative maximums and minimums. Well, at those locations, the tangent lines are horizontal. What's the slope of a horizontal line? 0. Okay. Now, if I go ahead and take the derivative of the function, If I set it equal to the slope 0, because I know that that's the slope of the tangent line at those points that I want, solving for x is going to give me the location that I need. Okay. Now, here's the thing. Nobody in here raised your hand. Only one person today has actually been able to give me the derivative. Could anybody look at that function and tell me what the derivative is? Okay, that's fine. In 3 weeks' time, I'm going to go ahead and use this formula, f of x plus h minus f of x all over h. That's what we call the difference quotient. This is how I'm going to go ahead and first teach you to find the derivative of a function. Okay, but for right now, I'm just going to go ahead and give it to you. The derivative of this guy would be 3x squared minus 4. Okay, if you don't understand how I got that, don't worry about it. Okay, you're not responsible for this right now. If I ask you to find a maximum or a minimum, you can use what? The calculator. Okay, so I just want to go ahead and kind of give you a little foreshadow of what's coming. Well, I'm going to set it equal to 0 because I want to know the value of x for the tangent line that has a slope of 0. That's always going to respond to the maximums and the minimums, the relatives. Well, solve this equation for me. Okay, how would I solve this for x? First, we'd add 4. So 3x squared is equal to 4. Now what? Divide by 3. X squared is equal to 4/3. And how do I get x from x squared? Square root. Now, because I'm taking a square root, how many answers would I get? 2. It'd be positive and negative, right? So here's what I'm going to do. I'm going to now plug that in the calculator. This is the only time I'm going to rely on the calculator to help me with this. So I'm going to go back to my scratch pad, the square root. And I always like to put in fractions using control divide. It gives me that little fraction template. You don't have to do that. Okay. Over 3. Does that look familiar? Where did we say the maximums and the minimums occurred? See, it occurred at a positive and a negative 1.15. Okay, calculus. Okay, like I said, not responsible for that right now. I just thought it was a good opportunity to kind of go ahead and show you something new. Okay, if you're not sure how I did that, don't worry. Okay, you are not responsible in any way for that yet. Yes, ma'am. I'll usually tell you. I'll probably say like 10th or 100,000th, something like that. Okay. All right. So good. Good, good. Okay, let's go ahead and move on past this problem because that's all I wanted to show you there. All right. Last part of the notes, and then we're done. Even, odd, and neither. Okay, if you refer back to the first page of notes in this lesson, that at the very bottom talked about the difference between those, and there was a test. If I can take a function and replace every x with its opposite, okay? If by doing so, after I simplify, I get the original graph back, no changes, that tells me it's what, man? That's even. There we go. That's correct. Now, if I can perform the same test, replace every x with its opposite, but if I get the opposite of the original equation, that means every term's sign has changed. Positives became negative and vice versa. Everything. Then that's what? Odd. Now, if neither of those instances occur, well, then it's neither. Okay? That's what we're trying to determine here. Which of these relations, I can't say they're all functions because b is not a function. Which ones are even, odd, or neither? Okay. So let's take a look at A. It says f of x equals 4 minus x squared. This one's already in explicit form. It's y equals. We're good to go. So all we have to do is apply the test. Okay. I'm going to replace x with his opposite. So 4 minus x squared becomes 4 minus negative x squared. Okay. Now, just follow your order of operations. How would you begin to simplify this? Okay. So the negative x squared, okay. What happens if you're going to square that negative x? It's going to become positive. So this would be x squared, but now you would go ahead and subtract it. Okay, these two negatives wouldn't be able to interact with each other because it's part of the base. Well, you are squaring it, but see, this negative is still there. So ultimately, it becomes 4 minus x squared. Well, the x is still squared. Because, see, it's the unknown, because we don't know what it represents. That makes sense? Okay. Now, here's the question you need to ask yourself. I've simplified it. This is what I got to. Is it exactly the same, or is it the direct opposite in terms of sign from what I got? It's exactly the same. So what kind of function is this? It's even. Now, again, let me go ahead and elaborate. If I were to get the opposite, that means that both terms would change sign. If this were going to turn out to be an odd function, then I should have gotten negative 4 plus x squared. Every term sign from the original will change. Okay. Well, what kind of symmetry do even functions have? What axis? The y-axis. Yeah, if I go ahead and fold it along this y-axis, pretend to hit the y-axis. The two parts are going to come together perfectly. So I'm going to say it's symmetric. I'm going to abbreviate that. I like to go ahead and say with respect to, WRT, the y-axis. Now, unless anybody wants me to do this, I'm just going to go ahead and give you the general form. It says identify a pair of points that would justify the symmetry. So I'm just going to do the general. So if we have any point like xy, and I reflect it across the y-axis, what about the coordinate is changing? Is it x, is it y, or is it both? It's only x. In fact, you'll notice x is going to become its opposite. When you reflect across the y-axis, the x value is what's changing. Okay. Questions? Oh, absolutely. We're about to do B and C. Oh, yeah, we're getting there. We're getting there. Okay, so let's do B. Now, for the first time today, we're going to go ahead and get some people up to the front because you'll notice both B and C, it's not already solved for Y. So we want to solve it for Y before we go ahead and apply the test. Who would like to come on up and show me B? All you have to do is solve for Y equals. Whoa, 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 there's too many hands going up. I can't decide. Okay. All right, so I do have ways of encouraging people to come up because it's always an encouragement. All right, so what I'm going to go ahead and do, I'm going to go to menu, probability, random, integer. Okay, and this class here looks like number 30 is the highest one. Okay, so are there any volunteers before almighty technology? Galen, you want to do it? Okay, let's see who Galen is coming up here for. 13. That's 12, 13, so that's Fernanda. So are you okay with that, man? I want to make sure because I don't want anybody to feel left out. Okay. All right. So Galen, I want you to show me how to solve this for Y. Okay, so she's subtracting the x. Negative y squared equals negative x minus 2. Oh, and I forgot. Did you want the headphones?
Oh, I'm good.
Did you want to talk to the people?
Oh, I wasn't really talking. I just been...
I mean, you could if you want to. Say hi.
Hi.
Okay. There we go. She got rid of the negative.
And then square all that, y equals third x plus. Yeah. Okay.
Okay, you are perfect. There's just one detail.
Oh, the plus minus.
The plus minus. There we go. Okay. All right. Oh, you're asking her why she wrote it over the graph? I don't know. Okay. So she's absolutely right. In fact, if you think about one of the problems we did earlier in this lesson, you've got both a positive and a negative radical. See, with it being plus 2, it shifted it left 2. That's why the graph looks the way it does. Okay. So with this function, now I want to apply the test. So I'm going to say f of negative x equals, okay, plus or minus the square root, but instead of x plus 2, remember I'm going to replace the x with its opposite. Okay. Well, this is one of those rare occasions where there is absolutely nothing I can simplify. It's an even root. There's no like terms. There's nothing to take care of. So here's my question. Compare this to what Galen gave us. Is it exactly the same? It is not exactly the same, so even's off the table. Are they direct opposites? Okay. Now the plus minus, I mean, if you change plus minus, it's still going to be plus minus, right? So don't focus on that. Now, the x's did change. This x became its opposite, but what didn't happen? The 2's are still the same sign. That 2 would have had to have changed sign as well. So it's not its direct opposite either, so that eliminates what?
Odd.
It's odd. So this relation is neither even nor odd. Okay, so I'm just going to go ahead and put neither. But that doesn't mean that it wouldn't have symmetry. Bless you. Does this have symmetry? Yeah, with what? There you go. You can fold along the x-axis and the two parts come together. So I'm going to say we have symmetry with respect to the x-axis. Perfect. There we go. All right. Okay, now, before we even do anything to problem C, just based on the graph, can anybody predict? Even, odd, neither? Okay, already hearing a lot of odds. Why? It has rotational symmetry. Okay, so when we apply the test, that means we should be able to see what? The exact same or the opposite sign? The opposite. So let's see if that's what happens. Okay, so who wants to come on up and rewrite this for y? Y equals. Okay. Fernanda, your number was chosen a second ago. Did you want to come on up? Okay. Oh, Natalia, you want to do it? Okay. Let's see who Natalia is going to come up for this time. 23. Oh, so that would have been an empty disk. 2. Andrew, are you okay with that? Sure. Okay. All right. Okay. Natalia, help me out with C.
So,
Okay. Hello.
5 seconds.
Oh, they just dropped off the box today, so I don't have anything in. But thank you so much. Well, what day will you folks come by?
Usually Wednesday.
Usually Wednesdays?
Yeah, we
Okay.
just heard that.
Okay. Thank you so much. All right. So let's see. She went to it. So she's saying, is that the cubed root
Yeah, sorry.
of 1/2 x?
Yeah.
Okay. What do you guys think? I think that's perfect. That's absolutely right. If you want to get rid of a cube, you have to take the cube root. Okay. So here's our function. F of x equals the cube root of 1/2 x. Now let's apply the rule. I'm going to replace x with its opposite. So the cube root of, if I take 1/2 times negative x, that's just going to be negative 1/2 x. Okay. Now, unlike the previous one, there is one thing I can do here to simplify this. Okay. And let me ask you this question, and it'll probably help you out. Okay. I'm taking the cube root of a negative number. Is this going to go imaginary?
No.
Or not?
No. Odd.
Because it's odd. That's why. If you're taking an even root of a negative number, that's when it's going to go imaginary. But if it's an odd root, you're only going to have one possible answer, and it's always going to be the same sign as your radicand. Did anybody want me to elaborate on that? I'll give you an example. No? Yes? Okay. Let's say if I were to give you, this has nothing to do with this problem. What if I gave you the cube root of 8? What's that? 2. Because 2 times 2 times 2, right? But what if I give you the cube root of negative 8? That's negative 2. Because think negative 2 times negative 2 is 4 times negative 2. So you can take the root as long as it's an odd root. Even, that's when you run into a problem. Okay, so the only thing I can do here, I have no idea what's going to happen to the 1/2 x, but at the very least, I know that my answer is going to be negative because it's a cube root of a negative. Okay, now compare what Natalia gave us to what I have. Did it actually turn out to be the direct opposite? Yes. Okay, exactly right. So it does have odd symmetry. Okay, and you said symmetry with the origin, with respect to origin. Okay. All right. Now, if I were to go ahead and take a look at some general ordered pair, just like any random point xy, if I were to rotate this 180 degrees, well, what's going to happen to these values here? Is one changing, both? What do you guys think? It would be both. Both the x and y would change signs. They become their opposites. Okay. Does anybody want me to elaborate on that? No? Okay. All right. Question. Okay, so here's what I'm going to do first. We get out of here at 52, so we still have a good solid 20 minutes. I'm going to pass back your quizzes. Let you take a look at that. If you have any questions on that, we'll talk about that. And then we'll look at any questions you might have on the assignment. Okay. So, there you go. Jordan, Lane, Caleb, Bennett, Connor, Alex, Talia, Andrew, Will, Fernando, Tori, Luna, Kate, Adrian. There we go. Okay, Jake. Okay. Let's see. Emma. Okay, you're right there. Okay. There we go. And Sandra was over here. That's right. Sandra. Caitlin. Gosh. Clarissa. Okay. Josh. Okay. Philip was here. Cadence was over there. Laura's not here today. Vanessa. Okay, then I have Bennett. I can actually pass these back because you're in the grade book now. Yay. Marissa. Okay, then I have Kate. Cylindra. Tori. Vanessa. Sandra. Connor. Michael. Laura's not here. Jordan. Adrian. Alex. Caleb. Gabe. Lane. Let's see. Jake. Yep. Philip. Joel. Will. Xavier. Josh. And that's all I got. Okay. Okay, so there are your quizzes. Did we want to talk about those?
Wait, did you say something about right, you just say something about, let's say it was a fraction that was like 2/3.
Mhm.
So that would be 0.66666.
Yes.
Say that was a certain
Now that's rational.
fraction. So it would be rational.
Yes, it would be rational. What a lot of people, one of the most common mistakes on that problem was a lot of people came up to me after the fact. They forgot that the symbol was R minus Q for the irrationals. A lot of people thought that that was reals to the rationals, like a through symbol. That's what most people were telling me anyway. All right, so no questions on the quiz. All right, if you do change your mind, let me know. You have until next Friday morning, the 30th. You got just over a week by 8:05 a.m. If you want to go ahead and retake, remember anything 79 or below. What we're going to go ahead and do now, are there any questions on the homework? Okay. And the only thing I want to go ahead and tell you is that on numbers, 1, 2, and 3, go ahead and pretend that the graphs continue beyond what you see, that they are actually arrows. It's like the resource we're using doesn't always like to go ahead and do that. People might stop it. So, okay. So pretend there are arrows on that. Sandra.
Read the line with full, not.
Yeah, it looks like it has a dot right there, but I'm just going to go ahead and tell you, pretend it's an arrow. Okay. All right. So anything on the homework we want to take a look at? Hey, wait, what you got?
Would you do number 9?
Number 9. Okay. It says find the explicit form of the equation. What's that mean?
Solve for a variable.
Okay, solve for a variable, so we want it y equals. Then use a graphing utility to determine whether each relation is a function, and apply the vertical line test. Okay, so let's see. X squared minus y squared equals 25. In fact, can anybody tell me, just by looking at this, what kind of graph is that? Can you predict? Well, you're definitely going to have to take a square root. It's going to be linear. I heard hyperbola. Okay. All right. Well, let's see what it actually turns out to be. What would I do first? Now, remember, we just want to solve it for y. That is a difference of 2 squares. You're correct, though. Okay. So I would go ahead and subtract the x squared over. Okay. That cancels. So the negative y squared is equal to 25 minus x squared. Now what? Okay, divide by the negative, or multiply through, however you change those signs. Y squared is equal to, I'm just going to go ahead and say x squared minus 25. Would everybody agree? And how do I undo a square? Square root. Okay. So I'm going to go ahead and say this is plus or minus the square root x squared minus 25. Okay. Now, if I were just looking at x squared minus 25 below the radical, what would that actually give me? Oh, no, we can't simplify it because when you're taking a radical, and I'm actually glad you brought this up, this is one of the big misconceptions in math. If people have something like the square root of a squared plus b squared, they want to go ahead and say that's just a plus b. Okay. It almost makes sense when you think about it because you're taking the square root of both, but that's not the case. Okay. In fact, if you go ahead and choose, some values for a and b, it's never going to work out that way. Okay. Unless, of course, both a and b are 0. That's the one exception. Okay. For the general case, it's not going to work. So here, radicals, they're not big fans of addition and subtraction. So if it was like 25x squared, a product, then I could go ahead and simplify it. Or even if it was division, x squared over 25, then I could simplify that fraction. But when it comes to radicals, you want to be able to look at the entire group and not just the individual terms. Does that make sense? Okay. So this one right here would actually be a semicircle. Okay, with a radius of what? With a radius of 5. And because we have both plus and minus, it gives me the reflection. Yes, sir. Factor that out. You mean because it's a difference of squares again? I mean, you could go ahead and say plus or minus the square root of x plus 5, x minus 5, but I wouldn't think that that'd be necessary, especially for this problem. I would say you get to that point, you're good to go. Okay. So now if we're going to go ahead and sketch this, yes, we.
It comes out to a hyperbola in the calculator when you just put in the relation. It's
Now,
kind of odd.
but we're getting a semicircle. You know, that's right. It does fit the form of a hyperbola.
I don't know.
Let me look into that.
Ooh, I would
Okay,
also-
because whether or not it goes with the hyperbola or you do choose the circle, the good news either way is it's not a what?
it's not a function.
It's not a function.
So I
It's
was
just in this case, A would equal B.
I was also curious though that if you've got your x squared term, would x terms between -5 and 5 not fit the function since it?
You know what? You're okay. Hold on. Okay, I know exactly what William is saying. Okay, so let's take a look at this. Forget about the radical for a second. Okay, let me go ahead and get a better grid up here. Okay, let's see this. Let me get an actual nice grid. Okay, so I see exactly what he's saying. There's going to be values of x that aren't going to work here. So yes, I'm sorry, it's not a semicircle. If it was the square root of 25 minus x squared, that's a semicircle. I got confused on that. William's absolutely right. Okay, that is my fault. Okay, so what he's saying here, forget about the radical for just a second. It is going to turn out to be a hyperbola, but let's go ahead and sketch it as is. Forget about the radical. What would x squared minus 25 look like? It's going to be a parabola where what's that minus 25 doing to it? It's a vertical shift, right? It's going to pull him down to negative 25. So this is not going to be to scale. Let's say negative 25 is right here. So the parabola is going to be opening up. It's going to look like this, right? Now I'm talking more in terms of domain and range, but just what he was saying about certain values we can't have, I'm going to show you why. Okay. Now, where is it crossing the x-axis? It is 5 and negative 5. If I took that radicand, x squared minus 25 is equal to 0. X squared equals 25. So x equals plus or minus 5, right? So this is a negative 5. This is a positive 5. This is actually something that we're going to be talking about in a few weeks when we start looking at rational functions. But given this graph, where is it positive? And what am I referring to when I say the function's positive or greater than 0? And that's okay if we don't know. I'm talking about with the x-axis, because the x-axis represents 0 on the y-axis, right? Okay, so if I'm asking you for where the graph is positive, I'm asking you for any location where the graph is above the x-axis. So what would you describe any part of the graph being below the x-axis? That would be negative. Okay, so let me go ahead and put a different color on this. Okay, so we have our positive regions and we've got our negative regions. Now think of this graph in terms of the radical, the square root. Okay, what's the one thing we can't take the square root of? The negative. Okay, so any value of x that would result in a negative y value, we have to eliminate. So this portion here would be removed. Okay. So that's how we end up with the graph that we have left. Now this one, William is absolutely right. It is going to turn out to be a hyperbola. I'm really glad he brought up that point. Do you have to do that on this problem? Find the values of x that will or will not work?
Yeah, I mean either way.
In a manner of speaking, I mean you got to sketch it. Yeah, either way it's not going to be a function. I'm really glad you mentioned that. If I make a mistake, I'm willing to go ahead and say that I did. I was thinking at the beginning that was going to be a circle, and it absolutely is going to be a hyperbola. You're absolutely correct. Okay. Now, we went way further on this problem that you have to. Okay, but if you go ahead and sketch it, now, knowing it's a hyperbola, I would probably go ahead and sketch it by hand. I actually don't remember, where do you go, because there's a template you can use in the calculator, right?
You can just use a relation.
Where did you go?
I don't know how to change that. It's just kind of the default on my calculator.
Okay, so you just actually typed it in?
Yeah, I just typed it in as, I double checked myself and typed in x squared minus y squared equals 25 instead of the simplified version.
So you typed it in just right here?
Yeah, or not f of x, but if you like delete the f of x, then you can just type in. Oh yeah.
Oh, just your relation?
That's what I did. Is I looked at just sort of
Okay, and then you typed in x squared plus y squared.
minus y squared.
Or is it minus? Yes, sorry. Minus, and then it equals, where's the equal sign? Right here, 25.
That's
There you go. Okay. And so you'll notice there's no middle portion right here, because that's why what we were just saying, no values of x are going to work there because of the imaginary values. And then if you go ahead and put your vertical line, will it be hitting it in 2 or more places at once? Yes. Wow, that actually turned out to be a really good problem. We went way further than we needed to, but I'm glad we did that. Glad we did it. Okay, good, good, good. All right, so that one is a no. It is not going to be a function. Okay. Wow, we actually took a lot of time on that problem, but I think it was worth it. Bennett, what's up? Yeah, well, remember, this was only the positive version that I was looking at. Then we would have to do the negative square root of x squared minus 25, so it's going to flip it. So I just didn't complete the graph. Does that make sense? Okay. All right, good, good, good. That's fantastic. All right. We may have time to fit one more in if anybody has a question. Hey, Philip. 24. Oh, 24 is a good one. Okay. This one, you're basically going to go ahead and visualize what's happening here. If I remember correctly, Hayden leaves home to walk to school. He walks 2 blocks in 6 minutes at a constant speed. He forgot to bring his lunch. He runs home 3 minutes, yeah, yada, yada, yada. So the horizontal axis, what's that represent? Time. That's going to be the number of minutes. So this down here is going to be time. So the vertical is going to be what? The distance. In this case, we're talking about the number of blocks that he is from school. Okay. So draw a graph of Hayden's distance from school in blocks as a function of time. Label the axes properly. Okay, we've already got that taken care of. So he starts off at home. Now he's going to walk 2 blocks in 6 minutes. Where am I going to put my next point? There you go. It takes 6 minutes to get to 2 blocks, right?
It's home at 0.5 though, since you're 5 blocks away from the school. That's sort of...
Well, no, because he has to start at 0 because he's going to school. So when he starts at home, it's got to be 0.
It lists it as blocks away from school, so he's home is 5 blocks away.
Yeah, but well, since he starts off at home, though, he's not going to start off 5. I mean, I see what you're saying, but just for these purposes, we're going to go ahead and say, because even if you did invert it, you're perfectly fine. That's perfect. Okay. All right. Because I would still get the idea you know exactly what it is we're referring to. Does everybody understand what William is saying? Okay. All right. We're just going to go ahead and go from the idea that, we're starting at home. It's fine. Okay. But the key word here is what? Constant. So what's that telling me about how I want to connect these points? There you go. It's a constant. Linear functions have a constant slope. That's his rate of change. That's his speed. Okay. So now the next part, what happens? He forgot to bring his lunch, so he runs home in 3 minutes. Okay. So it took 3 additional minutes for him to get back home, where that distance is going to be 0. Does that make sense? Okay. And then basically, Philip, you asked about this? That's what you want to do. You just want to continue that story until you get him to school. Okay. All right. Now we have bell's about to ring. I do need all the calculators back up at the front before I can let you guys go. Let me go ahead and shut this off. Okay.